Okay, we are going to do the quotient rule. Gonna hide that. Let's go ahead and delete this. Oh, wow. I wasn't even done circling it. There we go. Okay, so see if this works again. Copy, copy, paste, paste, paste. Quotient rule. Okay, y'all. So the first-ish video, I think, second video that we did for 12.1, we looked at the product rule, and I'd explained that the product rule is used whenever you multiply things together. And your hint there is that the answer to a multiplication problem, you say it's the product, right? So if we're going to look at something that's a quotient rule, then that's going to have come from a problem where division is happening. It'll basically be something that's written in a fractional form. So you have a top and you have a bottom. So what we do is our actual rule, I'll show you right here. Our quotient rule is right here. And what that rule says is if you have a base, if you have a number, if you have a variable, if you have something up top being raised to an exponent, whatever that exponent may be, and, that's close, and you have it divided by, it's not a different something, it's the same something, it's the same base, it's the same variable, also raised to an exponent. Now, the reason why I didn't use m and m for the numerator and the denominator was because that would imply that the only time you could use this rule would be if your exponents were the exact same. And that's not true. Your bases have to be the exact same, but your exponents do not have to be the exact same. The reason why your bases have to be the exact same is because the rule tells us to keep our base, right? There's another step too, but just to clarify this, because I'm going to keep my base, if they were different, I wouldn't know which one to keep, right? Like, how would you choose between a 2 and a 3 or a y and a z? You wouldn't be able to. So the bases are the same because the rule tells us to keep our base, and what we do is we subtract our exponents. The product rule, remember, was keep and add. This is keep and subtract. Okay, so that's going to be what we do if we have bases dividing each other and they're the same base. Let's go ahead and do this example. What I have is 5 over, I'm sorry, why did I say over? 5 to the 8th power over 5 to the 3rd power. Are those the same bases? Well, what's being raised to an exponent in my numerator is the value 5, and what's being raised to an exponent in my denominator is also the value 5. That means that my base, in both spots is the same, which is 5. The rule says to keep your base and subtract your powers. So we get 5. 8 minus 3 is 5. So the answer would be 5 raised to the 5th power. The homework may have you evaluate this because your exponent is less than 7. But if it doesn't and it tells you to leave your answer in exponential form, then that right there would just be your answer. Okay, so now let's do this example. It's a little bit more involved. In the numerator, we have 3 squared x to the 5th over, in the denominator, we have 3, just kidding, 3 to the 4th power, and then x squared. So I noticed that I actually have 2 different things being raised to an exponent, so I need to look at the bases. In the numerator, I have a 3 being squared, and so that would mean that my base is 3, my exponent is 2. And then in the denominator, I also have a 3 being raised to any exponent. I really don't care. The only thing I care about is that my bases are the same. So that tells me, okay, I can apply the rule on my bases that are 3s. So what I would do is write 3, and then what you do is this is kind of a combination problem, y'all. I didn't mean for it to be, but it is. What I would do is keep the base, subtract my exponents. Now look at your next term. I have an x being raised to the 5th power. Well, in the denominator, I have an x being squared. Same basis. Keep, subtract. Now, if you look at the 3 raised to the 2 minus 4 power, I'm subtracting there, so I get 3. 2 minus 4, signs are different, so you subtract, keep the sign of a larger. I get 3 to the negative 2. And then for my x, keep the base and subtract, I would get x cubed. And then the question would be, am I done? What I meant by this is kind of a combination problem is because this problem actually combines what we learned about negative exponents. I didn't particularly want to do that, but it looks like in my notes I accidentally did. No, I wouldn't be done, right? Because in order for it to be a correct answer, there can't be any negative exponents. Because that 3 to the negative 2 is not in a fractional form, like in the denominator, what you do is we would put it in the denominator. That makes it a positive 2. This remained in the numerator. It did not go anywhere. So it just stays in the numerator. Homework would probably want you to evaluate that because we can, right? 3 squared, 3 times 3 is 9. Quotient rule. 5, 8, 3, 2, x to the 5th. That is the, that is both of the problems that I wanted to do for the quotient rule. I can't think of anything else either. I'm looking over at my notes. Quotient rule, same bases, because they're dividing, keep the base and subtract your powers. Okay, y'all, that's it for this video. If you have any questions, make sure you ask, okay? I'll be back to do about 5 problems combining all of these rules. I had 4 or 5. Okay, thanks. Bye.